Hello, my name is Daniel, and today we will be going through the AMC 10B from the year 2017. So let's get started. First problem, Mary thought of a positive two-digit number. She multiplied it by 3 and added 11. Then she switched the digits of the result, obtaining a number between 71 and 75 inclusive. What was Mary's number? Okay, so first, it said that Mary got a number between 71 and 75, right? But then, the common thing between all of these numbers is that their tens digit is 7, right? So her results tens digit is always going to be 7. But then she switched the digits, right? And so that means her number before she switched the digits was something 7, right? The units digit was 7. But then since she added 11, then the number before she added 11 would be something and 7 minus 1, so the units digit would be 6, right? But then before she added 11, she multiplied it by 3, right? And so so the number before she multiplied by 3, the units digit of that would be something 2, right? And if you see here, the only answer choice with a units digit of 2 is 12b. And if you do want to check this, then you can do this. If you multiply 12 by 3, that's 36. If you add 11, that's 47. And if you switched the digits, then you do 74, and 74 is between 71 and 75. The answer is B. Number 2, Sophia ran 5 laps around the 400-meter track at her school. For each lap, she ran the first 100 meters at an average speed of 4 meters per second and the remaining 300 meters at an average of 5 meters per second. How much time did Sophia take running the 5 laps? Okay, so each lap she ran for the same time, so we can just get 1 lap time and multiply that by 5. And she ran the first 100 meters at average speed of 4 meters per second, so that's 25 seconds. And the remaining 300 meters she ran at 5 meters per second, so that's 60 seconds, right? And then it's 25 seconds plus 60 seconds for 1 lap, but then she ran 5 laps, so we have to multiply by 5. This is, first, this much is 5 minutes plus, and this much is 125 seconds, so this is 7 minutes 5 seconds. The answer is C. Problem number 3. Real numbers x, y, and z satisfy the inequalities. X is between 0 and 1, y is between -1 and 0, and z is between 1 and 2. Which of the following numbers is necessarily positive? Okay, so if x is like 0.1 and y is -0.99, then that doesn't make sense, so A is gone. And y plus xz, what if x is like 0.1 and z is 0.1? No, actually, and z is 1.1, right? And y would be like -1, right? And then so these two multiplied, their absolute value would be less than -1, so that would also be negative, and so that's also wrong. And if you take a look at E right here, y plus z, then y is between -1 and 0, z is between 1 and 2, right? And so if you add these up, y plus z is greater than 0 and less than 2, and so this must be necessarily positive. The answer is E. Number 4, suppose that x and y are non-zero real numbers such that this is true. What is the value of this, right? And so let's just cross multiply this, so that would give us 3x plus y equals negative 2x and then plus 6y, right? And so 5x equals 5y, so x equals y. And so if we put that in here, then that gives us, since x equals y, let's just say it's all x. And so it's 4x over 2y. No, 4x over 2x. Well, they're the same anyway. This is 2, so the answer is 2. It's D. Number 5. Camilla had twice as many blueberry jelly beans as cherry jelly beans. After eating 10 pieces of each kind, she now has 3 times as many blueberry jelly beans as cherry jelly beans. How many blueberry jelly beans did she originally have? Okay, so let's say the number of cherry jelly beans that she had at first is x, right? So cherry is x, then blueberry equals 2x, right? And after eating 10 pieces of each kind, she now has 3 times as many blueberry jelly beans as cherry jelly beans. So 2x minus 10 equals 3 times x minus 10, right? X minus 10, right? And so and this would be 3x minus 30. So if this goes here and this goes there, then x would equal 20, and we are looking for the number of blueberry jelly beans, which is 2x. So 2x equals 40. The answer is D. Number 6, where's the largest number of solid 2 by 2 by 1 inch blocks that can fit in a 3 by 2 by 3 inch box? Okay, so this is actually pretty easy if you can just visualize the box, right? And so we're trying to cram in 2 by 2 by 1 blocks into this 3 by 3 by 2 in this 3 by 2 by 3 box, right? And so so it doesn't matter like what the width or the height is. It just matters that it's 3 3 2 because it's like a box, right? And so let's say this is our box. It's kind of it's laying on its side, but then here's the box, right? So we have 3 inches here, like that, and this is 2 inches, right? And so we can have 2 boxes like this, right? 2 boxes right here, like that, right? And so that will be 2 boxes, and right here on the side we can have 1 more box like that, and 1 more box like that. So that will be 2 more boxes, right? So plus 2 equals 4. The answer is B. Number 7, Sammy set off on her bicycle to visit a friend traveling at an average speed of 17 kilometers per hour. When she had gone half the distance to her friend's house, a tire went flat and she walked the rest of the way at 5 kilometers per hour. In all, it took her 44 minutes to reach her friend's house. In kilometers rounded to the nearest tenth, how far did Sammy walk? Okay, so let's say that the length that Sammy walked, this is x, right? X kilometers, right? And so since she went half the distance before she had to walk, that means that she traveled the distance of x even when she was on her bicycle, right? So it's x over 17. This is the time it took when she was riding her bike, plus the time it took when she was walking. So it's x over 5 equals 44 minutes. So 44 over 60 hours, right? And so we can divide by 4, and that will be 11 over 15, right? And so we can cross multiply, so we can multiply by 5 times 17, right? 5 times 17 to this and to this. And so this is 22x. Actually, this should be 5x plus 17x, and then let's go to 22x. And then this equals, these two cancel, so it's so it's 11 times 17 over 3. 11 times 17 over 3, and these two cancel to make 2. X equals 17 over 2 times 3 equals 17 over 6. So this is 2 and 5 over 6, right? And the only number that is over 2.5 but less than 3 is 2.8, so the answer is C. Number 8, points A 11,9 and B 2,3 are vertices of triangle ABC with AB equals AC. So if we draw a triangle right here, this would be the triangle, and we would have A, B, C. And this looks like an equilateral triangle, but it doesn't have to be. Just these two have to be same, right? And the altitude from A meets the opposite side. Okay, so we have to have an altitude from A, and this will be D at -1,3, right? And so we want this point's coordinates, right? And B is -2, B is 2, -3, 2, -3, and D is -1,3, right? And since B, D, and C are all on a line, and this is equilateral, so that means BD and DC is the same length. Okay, so that means the amount of the x increase and the y increase from B to D will be the same amount of x increased and y increased from D to C, right? And so from B to D, that will be x will increase by -3 and y will increase by 6, right? And so same thing to here, -3 and 6. And so C, this will be -1 minus 3, -1 minus 3, comma 3 plus 6. So this is -4, 9. So the answer is -4,9. It's C. Number 9. A radio program has a quiz consisting of 3 multiple-choice questions, each with 3 choices. A contestant wins if he or she gets 2 or more of the questions right. The contestant answers randomly to each question. What is the probability of winning? Okay, so there are 3 multiple-choice questions. So he or she should get 2 or more right. So 2 correct and 3 correct. Those are the only ways that the contestant will win, right? And so we have 3 multiple choice questions. So if the contestant gets 2 correct, right? Let's look at that first. Then that means 3 choose 2. So choose which ones to get right, and multiply by 3 choices. So 1/3 times. So 1/3 squared for the correct ones times 2/3 for the incorrect one. And this is just 1/3 cubed, right? Because it's all correct. And so this is all over 3 cubed, and then 2 times 3 choose 2, which is 3. So this is 6/27, and this is 1/27. So if you add these up, then that means it's 7/27, so the answer is D. Number 10, the lines with equations ax minus 2y equals c and 2x plus by equals -c are perpendicular and intersect at 1, -5. What is c? Okay, so we have, for this one, we have 2y equals ax minus c, so y equals a/2x minus c/2, right? And so the slope is, the slope is a/2, and for this one, the slope is -2/b, because if you want to turn that into another equation, y equals -2/bx and then minus c/b, right? And so this is the slope for those 2 equations, right? And so we don't need these. And these 2 are negative reciprocals. That means a/2 equals -2/b/1. These 2 cancel. This is b/2. And so since a/2 equals b/2, that means a equals b, right? And so we have to find c. So let's get to finding c. Okay, so since we know that it intersects at 1, -5, we can plug that into both equations. So a minus 2 times y, so plus 10 equals c, and so a will equal c minus 10. And 2x plus by equals -c, but b is equal to a, so let's just say b is a. So 2 minus 5a, because a is b, equals -c. A is c minus 10, we can plug that in here. So this will be 2 minus 5c plus 50 minus c. No, this equals minus c. So 4c equals 52, c equals 13. The answer is E. Number 11. At typical high school, 60% of the students like dancing, the rest dislike it. Of those who like dancing, 80% say that they like it, and the rest say that they dislike it. Of those who dislike dancing, 90% say that they dislike it, and the rest say that they like it. What fraction of students who say that they dislike dancing actually like it? Okay, so let's look at this high school. Let's say that there are 100 people in total, right? And so 60% like dancing. Okay, so this is the like side, this is the dislike side. So 60 like dancing, the rest 40 don't. Of those who like dancing, 80% say that they like it. So here's saying like and not saying like. 80%, so 8 times 6 is 48. And the rest is 6 times 2 equals 12. So 12 like, but say they dislike. And of 40, 90% say that they dislike it. So 90% say that they dislike it, which is 4 times 9, 36, and the rest say that they like it. So 4. And so this much is dislike, and say that they dislike, right? And so what fraction of students who say that they dislike dancing actually like it? So out of 12 and 36, which actually like it? So 12. This equals, if you divide by 12 on the numerator and the denominator, that gives us 1/4. The answer is 25%, because 1/4 is 25%. Number 12, Elmer's new car gives 50% better fuel efficiency. However, the new car uses diesel fuel, which is 20% more expensive per liter than the gasoline the old car used. By what percent will Elmer save money if he uses his new car instead of his old car for a long trip? And let's hope that another oil crisis doesn't break out. So let's say that Elmer's old car would go 2 kilometers per hour. 2 kilometers per liter, right? So 1 liter would sustain him for 2 kilometers. And since the new car gives 50% better fuel efficiency, new would give 3 kilometers per liter, right? But then the diesel fuel is 20% more expensive per liter than the gasoline the old car used. And so let's say that the gasoline cost $5. Then diesel fuel is 20% more expensive, so it will cost $6, right? And so, by what percent will Elmer save money if he uses his new car instead of his old car for a long trip? Okay, so so the distance is not specified. So let's say it's 6 kilometer trip, 6 kilometers trip. And so this would use 3 liters and this would use 2 liters, right? But then the old one uses $5 fuel, so this is 3 times 15, $15. But then this is 2 liter with $6 fuel, so that would give us $12, 2 times 6. And so by what percent will Elmer save money? So it's 15 minus 12 over 15, which is 3 over 15, which is 1 over 5, which is 20%. So the answer is A. Number 13, there are 20 students participating in an after-school program offering classes in yoga, bridge, and painting. Each student must take at least one of those 3 classes, but may take 2 or all 3. There are 10 students taking yoga, 13 taking bridge, and 9 taking painting. There are 9 students taking at least 2 classes. How many students are taking all 3 classes? Okay, so there are 20 students in total, and there are 10 students yoga, 13 bridge, and 9 taking painting. And so if we add them all up, then we have 32 students. 32 people who enrolled in classes in total, right? But there are 20 students, right? So the number of overlaps equals 12, right? So there are it said there are 9 students taking at least 2 classes, so 3 classes equals 12 minus 9 equals 3. So the answer is 3. It's C. Number 14, an integer n is selected at random in this range. What is the probability that the remainder when n to the 16th power is divided by 5 is 1? Okay, so since we're talking about when n to the 16th power is divided by 5, n can be 5x plus 0, or 5x plus 1, or 5x plus 2, or 5x plus 3, or 5x plus 4, right? But first of all, when n is 5x plus 0, n to the 16th power divided by 5, so the remainder of that will be 0 to the 5th power, 0 to the 16th power, which is 0, so it's not 1, so this is not going, so the remainder of that won't be 1. And for 1, it will be 1 to the 16th power. By the same logic, this is 1, and so it is 1, so this one counts. For 2, it's 2 to the 16th power, and if we write out some powers of 2, that will be 2, 4, 8, 16. This is we're just interested in the units digits, so 16 and then 32 and then 64. Okay, so we can see that 2, 4, 8, 6 is getting repeated, and 16 is a multiple of 4, so this will end in 6. Right, but then we have to divide by 5, so the remainder of that will be 1. So this is also a remainder of 1. For 3, 3 to the 16th power, and the same thing we did with this, 3, 9, 27, 81, and then times 3 again. Okay, so this 3971 cycle. So this is 1, right? Because 16 is multiple of 4, so that one also counts. And for 4, this is 4 to the 16th power, and so that would be 4 to the first power is 4, and then 16, and then 64, so 4, 6, 4, 6, 4, 6, like that, right? And so 16 is an even number, so this also ends in 6, and then by the same logic with this, the remainder will also be 1, so this one also counts. So of our 5 possibilities, 4 meet this condition, so this is 4 out of 5. The answer is D. Number 15, rectangle ABCD has AB equals 3 and BC equals 4. Point E is the foot of the perpendicular from B to diagonal AC. What is the area of AED? Okay, so let's say we have a rectangle A, B, C, D, like that, right? And so AB is 3 and BC is 4, so A, B, C, D, like that, right? And so this is 3, this is 4. Point E is the foot of the perpendicular from B to diagonal AC. So we have diagonal AC like that, and we have the perpendicular from B to AC like that, right? And so this is E. What is the area of AED? So we'll have to draw another line like that, right? And so we are trying to get this area, right? But then if you drop a line like that from D to AC, and this one make it also perpendicular, this is also perpendicular, right? And then you will see that BE and this length is exactly the same, right? And this is the height of AED if you look at AE as the base, right? And so if AE is the base, then this length will be the height, right? But then since this length equals this length, then that means that AED, this triangle area, is equal to the area of AEB, right? And so to get the area of AED, this equals the area of AEB. And so since this length is 3 and this length is 4, that means this length is 5, and the ratio of the and the ratio of the lengths are 3 to 4 to 5. That means this is 3 to 4 to 5 also, right? But then since this is 3, this means BE is 4 over 5 times 3, and this is 3 over 5 times 3, right? And so AEB equals half times this, which is 9 over 5, times this, which is 12 over 5. And so this equals, these two cancel to go 6, and 6 times 9, 54 over 25. So the answer is 54 over 25, which is E. Number 16, how many of the base 10 numerals for the positive integers less than or equal to 2017 contain the digit 0? Okay, so first of all, our possibilities are the numerals being 2, 0 is 2 something something something, or 1 something something something, or just something something something, with this being from 1 to 9, and just something something with this and two-digit number with this being from 1 to 9. And that's it, right? Because this just 0, that's not that's not counted, right? And so first of all, 2 something something something, it's 2000, this is 2000 to 2017, and all of them contain 0 at the hundredths place, right? So that will be 18 numbers, and 1 something something something, that if we have the so if we allow the digit 0, that will be 10 possibilities. But if we don't allow the digit 0, then that will be 999 possibilities, right? So that gives us, this is 10 cubed minus 9 cubed, which is 1000 minus 729, and so this is 271. This is 271, and from 1 to 9, and same logic as before, if we had zeros, it would be 10 10, but since we but if we don't, it will be 9 9, right? So this will be 1 to 9, so we have 9 for that, times 10 squared minus 9 squared, 10 squared minus 9 squared, and so this is 9 times 100 minus 81, which is 19. Right, and so this is 81 times 9, so this is 171, and this will be with 1 0, right? So 10, 20, 30, 40, all the way to 90, and so this will be just 9. And so if we add these all up, then we will get, from this we get 180, and from this we get 289. So if we add these up, we get 469. The answer is A. Number 17, call a positive integer monotonous if it is a one-digit number or its digits, when read from left to right, form either a strictly increasing or a strictly decreasing sequence. For example, 3, 2, 3, 5, 7, 8, and 9, 8, 6, 7, 9, 8, 7, 6, 2, 0 are monotonous, but these are not. How many monotonous positive integers are there? Okay, so first thing that we should see is that we can have two cases where the integer is strictly where the integer's digits are strictly increasing or strictly decreasing, right? So we have those two cases. And let's look at the strictly decreasing sequence first. Decreasing means that we can have 0. We can have 0 at the end, right? And so we have 10. So that means we can have 10 choose 2, no, 10 choose 1 for the one digit numbers, 10 choose 2 plus 10 choose 2 for the two digit numbers, 10 choose 3 for the 3-digit numbers, 10 choose 4, all the way to 10 choose 10, right? Which will be 9, 8, 7, 6, 5, 4, 3, 2, 1, and 0, right? And for the increasing, cannot no, so we cannot have 0, so no 0, and so that would be 9 choose 1 for the integers, plus 9 choose 2, 9 choose 3, 9 choose 4, all the way to 9 choose 9, right? And in which case it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But then see that if we just have 9 choose 0, then this becomes 2 to the 9th power, and if we have 10 choose 0, then this becomes 2 to the 10th power, right? And also one more thing, this and this overlaps, right? And so this even includes 0, right? So this is 0 to 10, and no, this is 0 to 9, and this is 1 to 9, but we only need one of the one of the one-digit numbers, so just one of each. So we can just take these out too, right? And so so our answer would be these two, 2 to the 9th power plus 2 to the 10th power minus 10C0, 9C0, and 10C1. 10C0, 9C0, 10C1 plus 10C1, right? And so this would be 512 plus 1024 minus, and then this is 12, so 12. And so that would be 500 plus 1024 equals 1524. It's 1524. The answer is B. Number 18. In the figure below, 3 of the 6 discs are to be painted blue, 2 are to be painted red, and 1 is to be painted green. 2 paintings that can be obtained from one another by a rotation or a reflection of the entire figure is considered the same. How many different paintings are possible? Okay, so we have 3 of the 6 discs are painted blue, right? And so we can first choose which discs will be painted blue, and that will very much limit the choices of the other colors. So we can have blue on, so we can have blue here, so that would look like this, and it would not matter which one is red, right? Because rotation or a reflection of the entire figure, that's just the same, right? And so red, green, so that would be 1, and that's it for the combinations with B like this. And so now what if B is like this, right? That would also be B, and we would have R, G, and that's just 1 because when we rotate the G, that's the same as rotating the whole thing. And so in the same way, we can have B like this, and we can have actually 2 different kinds of things. The green can be at the top, or the green can be in the second row, right? So the top will be red, and this will be green and red, right? And the reason that we're not doing red green is because that would be a reflection of the whole thing, right? So it's the same thing. And what if the B's are like this? So the 3 will be at the top, and this will be red, green, red, or this can be blue with green, red, and those two will be different because this time G is in the center, but this time G is at the edge, right? So that will be 6 possible things, right? And next one is if B is like this. So if B goes like this, then if green is here, and if green is here, and if green is here, that's all different, right? So we have 3 more. And Now lastly, what if b is like this, right? And so this time also, whether green is here or here or here, that will be all different, right? And so we can also do plus 3. And so from that we can have 6 separate ones, plus 3, which is 6 plus 6 equals 12. So the answer is 12, it's D. Number 19, let ABC be an equilateral triangle. Extend the side AB beyond B to a point B prime, so that BB prime equals 3 times AB. Similarly, extend side BC beyond C to a point C prime, so that CC prime equals 3 times BC, and extend side CA beyond A to a point A prime, so that AA prime equals 3 times CA. What is the ratio of the area of triangle A prime B prime C prime to the area of triangle ABC? Okay, so this will be our diagram here. And what we have to do is we just have to do 3 simple things. We just have to draw 3 lines. So we can draw a line from C to B prime also, and we can draw the line from A to C prime. And boom, we have our answer, because if we see that this area is 1, then since since ABC and these, they share the same height but have 3 to 1 3 to 1 width, right? Then this would be 3, right? By the same reasoning, this would be 3, right? But then now look at this. No, but now look at this one and this big one, right? Then those two have the same height, but then the width is different, right? So this area would be 3 times that of this, and so that would be 9. This would also be 9. This would be 9 by the same reasoning. And so triangle ABC, this would be 1. But then A prime, B prime, C prime, this would be 1 plus 9 plus 9 plus 9 plus 3 plus 3 plus 3, which is 12 times 3 plus 1, which is 37. Right, so the ratio of the area this to this is 37 to 1. The answer is E. Number 20, the number 21 factorial equals 5109094217170944000 has over 60,000 positive integer divisors. One of them is chosen at random. What is the probability that it is odd? Okay, so we're dealing with 21 factorial here. So first we want to factor this, because we want the probability that it is odd, right? And so if we factor this, so first 21 factorial is 1, so we don't write that down because that's just 1, and then 2 times 3 times 4, which is 2, and 5 and a 6, which is 2 times 3, and 7, which is prime, 8 times, which is 2, 9, which is 3, 10, which is 2, 5, 11, which is prime, 12, which is 2, 3, 13, which is prime, 14, which is 2, 7, 15, which is 3, 5, 16, which is 2, because I'm running out of space, and we got to 16, right? So 17, that's prime, 18, that's 2 times 3 times 3, and 19, that's prime, 20, that's 2 times 2 times 5, and yeah, that's 20, and 21, that's 3 times 7. So if we count the number of 2's, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15, 18 2's. So it's 2 to the 18th power, and we have 9 3's, and we have 4 5's, and we have 3 7's, and we have 17, no, we have 11, 13, 17, 19, right? And so this is the prime factorization of this number, right? But then all we need here that is the probability that it is odd, right? And so 21 factorial, this is 2 to the 18th power times something times the other factors to some other factor, right? But then the odd numbers are just this to this power, right? Because if there's even 1 2, then that becomes even, right? And so the number of factors for 21 factorial, this is 18 times this plus 1. But then this is 19 plus that times 1, because it's 18 plus 1. And but then this one, it's just this plus 1. And this is this one right here, plus 1, right? And so the probability that it is odd, that is the probability that it is one of these out of these. So it's square plus 1 over 19 times square plus 1, which is 1 over 19. The answer is B. Number 21, in triangle ABC, AB equals 6, AC equals 8, BC equals 10, and D is the midpoint of BC. What is the sum of the radii of the circles inscribed in ADB and ADC? So this is the drawing, and ADB and ADC. So AB is 6, this is 6, AC is 8, and BC is 10, but then D is the midpoint, so this is 5 and 5, right? And so we need the sum of the radii of the circles. So if we just drop down like that and drop down to AB like that, then we will get where the centers are. And if we know where the centers are, we can put the line to the point of tangency like that. And since this whole thing is a 3 to 4 to 5 ratio triangle, this will also be a 3 to 5 will also be a 3 to 4 to 5 ratio triangle, right? And since this is a right angle, that means that this will also be 3 to 4 to 5, and by the same reasoning, this is also right angle, and so the small triangle will also be 3 to 4 to 5, right? But then this point is at the midpoint of AB, right? And so if we put AB in half, then this would be 3 and 3, right? And so since this much is 3, this much would also be 3. So 5 would be split into 3 of this much, and this much would be 2. And by the same reasoning, AC will be split in half because of this point, and so this will be 4 and 4, right? Since this is 4, this length and this length is the same, so 5 will be split into this length 4 and this length 1, right? And so we want the sum of the radii, right? So in here we want this length and we want this length, right? And since we know that this is a 3 to 4 to 5 triangle, and this is also a 3 to 4 to 5 triangle, and we know one of these lengths, right? Then let's just start getting the lengths. So the blue one, so the blue one will, so the blue radius, that will be 2 times 3 over 4, right? Because the ratio is 4 to 3, and so 2 times 3 over 4, this is 3 over 2. And so for the red one, the ratio is 3 to 4, right? So it's 1 times 4 over 3, so this is 4 over 3, right? And so the sum of the radii is 3 over 2 plus 4 over 3, which is all over 6, and then 6 plus 8, 9 plus 8, and 9 plus 8, which is 17 over 6, right? So this is 17 over 6. The answer is D. Problem number 22. The diameter AB of a circle of radius 2 is extended to a point D outside the circle so that BD equals 3. Point E is chosen so that ED equals 5, and line ED is perpendicular to line AD. Segment AE intersects the circle at point C between A and E. What is the area of triangle ABC? Okay, so this will be our diagram here. And the diameter is radius, and the circle has radius 2, so this is 2. And so this whole thing will be 4, right? And BD is 3, and ED is 5, and ED is perpendicular to AD, and this intersects at point C, that's this point right here. And so we want this area, right? And so since C is on the circle and AB is the diameter, that means that this is right angle. And so if we only get this length and this length, then we have our answer, right? And to do that, we have to use the property that these line lengths and this lengths are the same with have the same ratio, right? And so since this is 5 and this is 7, we can get the length of AE, right? So AE, this equals root 5 squared plus 7 squared, which equals 49 plus 25. This equals root 74. So AE equals root 74. And so what we want is the area of ABC. So BC equals, so BC over AB equals, BC is 5 over the hypotenuse root 74. And so BC is 5. So BC equals 5 over root 74 times AB, which is 4, right? And same for AC. AC equals 7 over root 74 times 4. So this is, so BC is 20 over root 74, and AC is 28 over root 74, right? What is the area of ABC? That would be BC times AC times half, right? So 20 over root 74 times AC, which is 28 over root 74 times 1/2. So this is 280 over, so this is 280 over 74. So the answer is 140 over 37, and the answer is D. Problem number 23. Let n equal this be the 79-digit number that is formed by writing the integers from 1 to 44 in order one after the other. We kind of noticed. What is the remainder when n is divided by 45? Okay, so 45, this equals 5 times 9, right? And so this is 9 multiplied by the remainder when divided by 5 of n over 9, right? N is divisible by 9, right? And so what we have to do is we have to get the units digit of n divided by 9, and see that to get the remainder when we divide n over 9 by 5, and we multiply that remainder by 9. So that's what we have to do. And so if you write out backwards from 44, 43, 42 until you find that value where the sum of all your digits is a multiple of 9, then that number will be starting from 37. So this divided by 9 will give us the units digit when n is divided by 9. So let's do that. So after we do all that, then the result would be that the units digit is 6, right? And so the remainder when n over 9 is divided by 5, that would be 1, right? Because of 6, and we have to multiply that by 9. So 1 times 9 equals 9. The answer is C. Problem number 24. The vertices of an equilateral triangle lie on the hyperbola xy equals 1, and a vertex of this hyperbola is the centroid of the triangle. What is the square of the area of the triangle? Okay, so this will be our hyperbola here, and if we make our equilateral triangle on the hyperbola with the centroid as the vertex, let's say it's this one, right? And so it would be like this. So this would be the centroid of the triangle, and one vertex lies on this point right here, because since this entire hyperbola it is like symmetric over this line y equals x, that means that the triangle must also be symmetric to that line, right? And so the only other vertex that is on that line is this one. And so since we know that this is 1, 1, and this is -1, -1, then this will be 2 root 2, right? And so this will be 2 root 2. Then since the whole thing is 60 degrees and this is 30 degrees, then if we put a line down there, then we can calculate this length. And so if we do that, that would be, since this is 2 root 2 and this is root 2, that this would be root 6, right? And so we have 2 times root 6. And so the area of the triangle will be 2 root 6 squared times root 3 over 4, and then the square of the area, right? So this squared would be 4 over root 3 times 4 times 6 squared, which is 6 root 3 squared. This is 36 times 3. The answer is 108. The answer is C. Number 25. Last year, Isabella took 7 math tests and received 7 different scores, each an integer between 91 and 100 inclusive. After each test, she noticed that the average of her test scores was an integer. Her score on the 7th test was 95. What was her score on the 6th test? Okay, so since all her scores are between 91 and 100, if we subtract 90 from every score, then that will not kind of change change the fact that the average of the test scores was an integer, right? And so she got 7 different scores from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 10 being 100, and her score on the 7th test was 95, so this was 5, right? And so we want the score on the 6th test right here, right? And so for the these first two test scores, their sum has to be a multiple of 2, these have to be a multiple of 3, these have to be a multiple of 4, these have to be a multiple of 5, these have to be a multiple of 6, and these have to be a multiple of 7, right? And so if we try to kind of like guess and check this, then since this has to be a multiple of like multiple of 7, and this one has to be a multiple of 6, what if this one is 30? Then this one will be 35, right? So the whole thing will be 35 if the one until 6 was 30, right? So let's try to make the sum 30, and for that, if we have 6 and then 2, that would be 8, so that's even. If we have 7, this would be a multiple of 3. If we have 1, then that would be 16, so that would be a multiple of 4. And then so 16 and then 4, that would be a multiple of 5 because it's 20. And then for 20 to make the for 20 to make the leap to 30, we need 10 at the 6th test, right? So the score on the 6th test is 10, so the answer is E, 100. So that was it for the AMC 10 from 2017, AMC 10B from 2017, and thank you for watching.